In this video, we're going to talk about radical functions. We're going to draw their graphs and talk about their domain and range. All right, so let's get started. We're going to start out with just the basic square root function. So based on what we've talked about in terms of square roots, what kinds of numbers can we put into the square root? We have numbers, we kind of have two things to mention, right? We have one that's a criteria, it has to be true, and one that is a preference, right? We'd like it to be true. So remember, we've said that a square root can only operate on positive values. So I have to choose numbers that are positive, 0 and up, right? So 0 would be the smallest number I could choose, and then I could go up from there. The numbers I prefer to take the square root of are ones that I can do nicely in my head, right? Those would be the perfect squares. That's not a requirement. It doesn't have to be a perfect square, but usually it's our preference. So with that in mind, I've already actually filled in some x values that are going to work nicely, right? 0 would be the smallest number I can use, and it's kind of important to include that one on the graph because the shape of this graph has an actual starting point. And so it's usually when we make the graph, it's good to identify the starting point. From there, I can go any way I like. If you don't care about using perfect squares, you could go 0, 1, 2, 3 if you want. Use your calculator and you're going to get some decimals over here for the y values, and that's okay. If you'd rather be able to do it in your head, then you might want to pick perfect squares, which we've talked about. So perfect square is a number times itself, like 1 times 1 is 1, and 2 times 2 is 4, and so forth. So those really make nice x values for this function. All right, so we're going to take our x values, we're going to plug them in and take the square root. The square root of 0 is just 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So if we plot those points on a graph, we'll be able to see what this shape looks like. So for our x's, we need to go up to 9. And for our y values, we need to go up to 3. So we have a point at 0, 0. That's that starting point we were talking about. From there, we're going to go in one direction. So the next point is 1, 1, 4, 2, and 9, 3. If you've done any graphing in the past, this shape kind of looks like half of a parabola on its side. We haven't quite talked about parabolas yet, but I'm guessing you might have seen one before. So that's the basic shape for a square root. And we're really only going to look at the graphs and the domain and range for a square root and a cube root. And so it would kind of be good to keep this in mind when you're graphing a square root. Let's add in the domain and range. What would be the domain for this function? You could think about this in two ways. You could think about our discussion about what kind of x's we're allowed to use, or you could use the graph now that we've drawn the graph. Remember, the domain is the x values, and they run from left to right. The smallest x value we can use, which is also on the very left of this picture, is 0. And there isn't a largest x value. We stopped at 9, but we could have kept going to 16, 25, or anything else. And this graph continues on to the right. Because we have a point there at 0, 0, and we want to include the x value of 0, and we use a bracket to show that. The range is going to be what we get out of our square root. We know that when we take a square root of something positive, we're going to get a positive number in return. So I'm not going to have a negatives, and again, I could also use the graph here. Remember, the range is the y's, and they go from lowest point to highest point. The lowest point is also here at the starting point. So it starts at its lowest point at 0, and then the y value is going up as we go to the right. So it's going to continue going up to infinity. We also have a y value of 0, so we would use the bracket to show that as well. We're going to come back to this shape in just a minute and talk about the domain a little bit further. But before we do that, I also wanted to go ahead and graph with you the cube root function so you could get an idea of what that looked like. So the basic cube root function, you can kind of use some of the same logic to make this graph. We don't have the same criteria that we have for a square root. I'm able to use negatives. Negatives are okay for an odd root. So I have chosen some negative values to plug in here, but our preferences are still the same. So while you could use any numbers here, -2, -1, 0, 1, and 2 would be fine. You may need to use your calculator and you may get decimal y values. If you would prefer to be able to do it in your head or to have your y values work out to be nice round numbers, perfect cubes are gonna work the best. A perfect cube would be a number that's multiplied 3 times by itself. So -2 times -2 times -2 would be -8, and that's a perfect cube. And so those are going to be working out really nice. So if I plug these in to calculate the y value, the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. We've got 1 and 2. This graph does not have a starting point. We do need to go from -8 to 8. Okay, so we've got a point at -8, -2, -1, -1, 0, 0, 1, 1, and +8, +2. So this, I sometimes describe this as like a swimming man. It's sort of like a twisted parabola where one end goes one way and the other goes in the opposite direction, sort of like that. This does kind of show that idea that a cube root maintains its sign. So if I put in a positive x, I get a positive y value up here at the top. If I put a negative x, I get a negative y value down here in the bottom. Okay, so let's put in the domain and range. From left to right, I really don't have a stopping point, right? I'm going to continue all the way left, and I'm going to keep going all the way right. Because we've said we can put in negatives, we can put in 0, we can put in positives, there's really no number that we can't use in a cube root. So it's going to cover all real numbers, negative infinity to positive infinity. The range from low to high, this as it goes to the left, it's going to be going down. And this branch, as it goes to the right, it's going to be going up. So the range is also all real numbers. I can get negatives, positives, and 0. So it's a little bit different than the shape for a square root. All right, let's go back to the square root function for a moment. And we want to take a minute to talk about maybe a square root function, but not this basic one that has an adjustment to it. So we'll start with this. So we want to find the domain, and I kind of want to show you 2 ways to do that. I want to show you how the domain relates to the graph, And then we'll show you another method that doesn't use the graph so that you can do both. Okay, so first let's try to make the graph for this function. What is the smallest number that I can put in for x? I'll give you a hint. It's not 0, it's smaller. So what number, if I used it for x, when I add 2, I would get 0. Right? And that would be -2. So -2 is the starting point for this function. Right? And that's because, I don't know if I can find a place to write this off to the side. That's because -2 plus 2 gives me 0. Right? What number, if I add 2, is going to give me 1? 1 would normally be the next perfect square. So I'll be able to take the square root of it very easily. Let's see, if I used -1, -1 plus 2 would give me 1, and then I could take the square root of that. Okay, we could kind of continue this logic. It works really well. It takes a little bit of thought, but it does help us get nice numbers. So what number, if I added 2, would give me 4? Definitely 2, right? And then the last one, we are looking for a number that if I added 2, I would get 9. And that would be 7. So these are going to make really nice x values for our function because when I plug them in, I add 2, I get the perfect square, which I can then take the square root of. So when I plug in -2, you can pause the video if you need to calculate this for yourself. Make sure you're convinced. -2 plus 2 would give me 0, and the square root of 0 is 0. -1 plus 2 would give me 1, and the square root of 1 is 1. 2 plus 2 would give me 4, and the square root of 4 is 2. 7 plus 2 would give me 9, and the square root of 9 is 3. So if we were to graph that, this time my starting point is at -2, 0. I have a point at -1, 1, 2, 2, and 7, 3. I still have the same square root shape. That really hasn't changed at all. Okay, now we're not going to really focus on this in our class, but I'm going to go ahead and pencil it in here anyway. This is something that you talk about a lot in college algebra. So if we were to compare this graph to the first graph we graphed in the beginning of the video, right? The first graph started at 0, 0, and this one starts at -2, 0. So it's the same shape, but it's been moved over or shifted. So we would say that this one has been shifted to the left by 2. Okay, and eventually you're going to look at some patterns, and we may give you a few assignments to try this out for yourself. And you're going to spend a lot of time in college algebra talking about how to shift graphs left and right. Okay, but given this graph, what would be the domain? Let's see if we can fit that in here. From left to right, my leftmost point is at -2, and I have a point there. And I'm going to continue going right forever to infinity. Okay, so one method for coming up with the domain is to think about the graph or look at the graph. If you have a graphing calculator, you can graph the graph first and think about it that way. All right, another way to do it without the graph is to focus more on the fact that the argument of a square root must be positive. Right? I have to have something positive here in order to be able to take the square root. And so if I wanted to write that in symbols, I would say that the x plus 2, the argument, must be positive. And we write positive means 0 or bigger, right? So it must be equal to or greater than or equal to 0. And then we could solve that for x. So I could subtract 2 from both sides. And that's going to be really consistent with what I see here, right? All the x values are -2 or bigger. From there, I want to write it in interval notation. I'm kind of squeezing everything in this little space. I'm sorry about that. Okay, but remember, for interval notation, the number line is just a helper. It's not the final answer. But if you didn't have the graph to look at, this might help you go from the inequality to the interval notation. We're definitely going to get the same answer as we got when we looked at the graph. But from left to right, we're going from -2 up to infinity. Okay, let me give you one more example. Let's see, I'll do it like this. This time we're not going to make the graph. It would be a little bit more complicated, but we are going to find the domain. So we could use that same procedure. We could take the argument. We're not changing the function, we're just having having a conversation about the argument. The 8 minus 5x, we want to make sure that that is positive. And then that's going to tell us about what kind of x values we can use. So we can take this and solve for x. So I'm going to subtract 8. I'm going to divide by -5. What happens when I divide by a negative? Right, I have to flip the sign. Okay, you can use a fraction or a decimal here. It doesn't matter to me. 8/5 is fine. I'm going to stick with that this time. If you would rather make it, what is it going to be? I think 1.6. That's fine too. We want to write it in interval notation. So I'm going to use this as a help. But if you can go straight to the interval notation, you don't even have to use the number line. It's definitely optional. This time, because I had to flip, it's less than 8/5. So if I were to draw the graph, it would sort of have an arc going that way, right, from my one point here. So my domain is going to go from -infinity up to positive 8/5. And that is that starting point. So I have a point there. So I'm going to use the square bracket. All right, I hope this gave you a great idea of how the function looks, what the graph might look like, and how to find the domain. Good luck with this, and we'll see you in the next video.